Hello, my name is Shubi, and I'm going to do my best to explain the lab technique known as titration. In this drawing, I've outlined a very common titration to use as an example. Titration is essentially the reaction between two samples where the goal is to find out more about one of those samples. In this case, the reaction will be an acid-base titration with hydrochloric acid and sodium hydroxide. So with an acid-base titration, one of the samples, in this case the hydrochloric acid, needs to be neutralized, and to do that we're going to use this base. Here we have a known concentration of acid and its volume, and we have a known concentration of the sodium hydroxide, the base. And we need to know how much of the sodium hydroxide needs to be used to neutralize all of the hydrochloric acid. In order to determine the volume of the base needed, we can use this equation. Here we have the number of moles of hydrochloric acid in the original molar equation times the concentration and the volume of hydrochloric acid, and then the same thing with the bases on the right. We can easily calculate the volume of the base required to titrate all of the hydrochloric acid, which ends up being 100 milliliters. Looking a little closer at how exactly the titration works, this diagram is helpful. In the original solution, only H plus and Cl minus ions are present. When the NaOH is added, the OH minus ions interact with the H plus ions and produce liquid water. This increases the pH, thereby neutralizing the acid. In addition, the Na plus ions and the Cl minus ions, they exist as simply ions. At the end point of a titration, all of the HCl will be gone and will be in the form of one of these products. And when more NaOH is added, those ions will simply exist in the solution and make the solution more basic as more NaOH is added. Some possible uses for titrations are determining an unknown concentration of a solution, neutralizing an acid or a base, for example in the human body, like in the blood or the stomach pH, or in the environment, like an ocean or a river or lake, or really anything else that involves determining more about an unknown solution can be considered a titration, and there are plenty of more examples. As always, remember to handle all the reactants and products with caution and follow all the safety guidelines. And in terms of efficiency, you can always plan out your titration ahead of time and determine everything that you do know about your solutions and what you're looking for, and that will help save a lot of time.